All right, number 77 on page 252. Area of a ripple. A stone is dropped into a lake, creating a circular ripple that travels upward at a speed of 60 centimeters per second. Find a function g that models the radius as a function of time. So the radius basically starts here, and the radius is going to come out at a certain rate. And basically it says the ripple travels outward, so that's the rate of the ripple. It travels outward at that speed. Distance equals rate times time. I guess that's a physics or math formula. So the distance as a function of time is basically, so for part A, the rate is 60 centimeters per second. So time is going to be in seconds, I guess. So the distance is actually our g function. So the distance as a function of time is the function we're calling g as a function of time, and it is simply 60 times t, where t is the input in seconds. Let's just make a note of that. The input of g is time in seconds, okay? But that's our g of t function. Sorry. Part B asks us to find a function f that models the area as a function of the radius. Well, area is pi r squared, as you know. So this function, this area function as a function of r, is the function we're calling f. So f of r is pi r squared. So this g function is inputting t and outputting the distance, the radius. So this function is inputting radius, and it outputs the area. So that's this one, f of r equals pi r squared. So then the last piece says, find the composition f of g of whatever input. You can call it x, you can call it t, you can call it r. I'm going to call it t because I know it's t. Because the first thing we're inputting into g is the time. So that is f of g of t. G of t is 60t. F is pi times r squared. And we're going to input that 60t. Sorry, I'm not able to grab my, there we go, sorry. So f of g of t is equal to pi times 60t squared. And I guess we could simplify that if we wanted to. I don't really want to, but I'm going to anyway, I guess. So there's my composition. Now, what does this function represent? Well, this is the function that you first plug time into g, and then g is going to output the radius, and then we're going to take that radius and we're going to input it into f, and when I input the radius into f, it outputs the area. So what does this function do? It takes an input of time in seconds and outputs the area of the ripple. Okay? So this is a function that gives you the area of the ripple as a function of time. That's what compositions do.